So probably you have some experiences in programming, like when in dealing with the file system. You may also wonder why the file system will not work for maintaining and keeping records of data. According to the knowledge you learn from the programming course, you know that we can save lots of data in files. The size can also be very big. We can handle the file with some program. Well, to answer this question, we need to see some limitations for the file system. First of all, for storing the data, the file system is very limited. And the size is limited by the disk or the address space. Also, when the system crashes, we may lose data, right? Because the file system is not very safe from the system crashes or failures. Also, even though we can use some password to protect some files, however, in most of cases, the password or the file-based safety, these kinds of protections are not sufficient. What's more, when dealing with files, we need to write a program, and different transactions may require different kinds of programs to run on the same file. In other words, we need to write a C++ or Java program for every new query, which may need to worry about the performance as well. This is a very big limitation. All the file doesn't have enough concurrency protections, and we need to worry about the interfering with other users, like we showed before, right? For the multiple users accessing the same accounts. And we also need to offer different views for different users. What's more, for the data we have in the DBMS, we may have to change the data very often, either the data or the data schema. And however, when we're saving the data in the file system, it's very hard to change the schema actually. So generally, the schema changes may need to change the file format, also need to rewrite all the data we have, and we also need to handle the application we have as well. This is the reason why the file system will not work, and also the motivation why DBMS is necessary. So you can see that DBMS is a very complicated system, and it also requires lots of basic data structure to help us maintaining the data we have in the system. So to model the data we have and translate everything into data structures, we need to have some models for us, which denotes the data models. Formally, data models denote some conceptual structuring of the data stored in the database systems. The data models we can use can be very simple records or the tuples, for example. If we store the data as a set of records, each one will have an ID, for example, and we can also have a bunch of attributes. If we take the students as an example, and we try to store all the students in the class into a DBMS, then each student will be described by a certain ID, like your FSU ID, as well as your name, your address, your courses, and photos, and etc. Besides the records, the data can also be a graph, where the nodes represent the cities and ages represent the airline routes. It's also another kind of data models we can use to model real-world data we have into some data structures. Here we also need to differentiate the schema versus data. Schema is very different from data. We need to make it clear. A schema generally describes how data is stored into a DBMS. It is defined at the setup time, and it doesn't change with the time. Therefore, it is also called metadata, as we see here. And the data actually is an instance of a database system. It denotes some concrete data we put there. And they may change rapidly with time. We can also think in this way, the schema is more like the type, and data is more like variables, as you learn from the programming courses. Or we can understand in this way, the schema denotes the class, and data denotes the objects. If we have learned C++ and Java, right, you should know what I'm saying about. So to help you understand what's the difference between schema versus data, we can also provide one example here in this page. And before that, we can show the difference between class and object first. It can help you understand what's the difference between schema and data as well. Let's assume we're defining one class in a programming language, because we don't know which language we're using right now, and we can write it in a very general way. For example, we can say we define class a car, for example, right? We define one class. Inside the class, we will have multiple variables, right? Describing what are the properties of the cars. First of all, we can define like the car should have a maker, right? We have one car maker, right? It is a string, and we can also have the string. Let me change the format. And we can also have the model, right? What's the model of the car, for example? And besides it, we can also have like some attributes like the color. What's the color of the car? We can also use string. And we can also have the VIN number. And the remaining ones, and like which year it is built, right? We can use int and etc. Let me reorder this attribute. We can put the year in front before the corner. This is a class we can define when we try to define some cars in our program. And when we try to create some objects for this class, we can use some language like this. Let me copy this. We can use the same font. Like we can define one object like my car equals to car, right? We can initialize all the attributes in the car, right, by calling an initialization function. For example, we have the maker. Let me reorganize this. Equals to, for example, Toyota. You can enter different kinds of makers depending on your car you have. We can have model equals to, for example, I'm using the Camry. And the year is like 2017, for example. The color I have is black. Let me use string. And the VIN, I cannot release my VIN for you. So we can enter some numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and etc. In this way, we will be able to create an object for the class, right? This is what we learned from the programming course in define class and objects. When we come to the schema, it will be very similar. However, they are representing different languages. To define schema in a database system, we have to use SQL, but we cannot define SQL here because we haven't touched the SQL yet. I can represent a very general way for the like if we also want to represent a car, the car will be like we have a schema name here. It has multiple attributes. We have like a char. We have a name of the char like 20 char maker. And we have the char like a 20 size and the model. It's comment. And we have like all the attributes like int. We also have int in the SQL. And we have char. For example, we have like 5 as the corner, as well as like a VIN is also char. Probably we have longer char for him. Then it will be a schema we can define for cars in SQL. We will show this later. And we come back to the data we can store inside our DBMS. Then we can use the table here. When it comes to the data we have, it will be some concrete data samples or data instances. Here we have some different cars. We can have Toyota. We have Camry. We have year. We have color. We have VIN. Right. We can also have some different cars like Honda. like Civic, like 2015, white, VIN is 3, 4, 5, 6 in essential. And we can also have some other cars like a high-brand car like Tesla, the Model 3, and 2019, like a gray. VIN is 5, 6, 7 essential. And you can have different cars here. There are some concrete examples. So this is called schema, and this one is called data we have in the system. So you can differentiate the difference between these two, right? Okay, so that's it for the example.